Do you have a non-technical background and you're trying to break into data analytics? If so, today's episode is for you. I had the chance to sit down with Marijn Markus, a data manager at Capgemini, and talk through his journey from a non-technical background in social science to becoming a senior data scientist and data manager. We talk about how you don't have to be perfect. You don't have to know everything. It's actually okay to use your prior background in your data role. It actually will become your superpower. If that sounds interesting, keep listening. Let's get into it.
Welcome to the Data Career Podcast, the podcast that helps aspiring data professionals land their next data job. Here's your host, Avery Smith.
As always, welcome back to the Data Career Podcast. If you're new here, welcome. My name is Avery Smith. I'm a senior data analyst and a data analytics career coach and the host of the Data Career Podcast. And my whole goal is to help you land your first data job. That's everything I'm here to do. I have some resources in the show notes or the description down below that I want you guys to check out to get some of that help. In today's episode, like I said, we're talking to Marijn Markus, who has some really fascinating information. But before we get into it, I just want to take a few moments and thank you guys as podcast listeners, because the podcast has really been blowing up recently, and it's all because of you guys liking, rating, and leaving reviews for the show. We have over 100 5-star ratings on Spotify, which is absolutely incredible. Thank you guys so much. And we have over 50 on Apple Podcasts, which is absolutely amazing. I work hard. I pay an editor to edit these podcasts. It's all free for you guys. We don't even have sponsors. If you guys want to support the show, one of the easiest ways that you can do it is just by leaving a rating on Spotify or Apple. Just click 5 stars. Should take you 30 seconds, and it really helps the show grow. If you're on Apple and you want to help the show even more, you can leave a short rating or review, which basically you just say a few sentences about why you like the podcast. Doing either of those really helps the show move forward and find other people like you who need help in the data world. And it also keeps me really happy and motivated to create more content for you guys down the road. So we'll keep the show free. Just leave that rating and review, and it really helps the show out. Share with a friend, and thank you guys so much for listening. Let's get into today's episode. I'm really excited today because I have an awesome guest coming from the other side of the pond. We have Marijn Markus, who is from the Netherlands, a managing data scientist at Capgemini, has lots of years of experience in the data science field, lots of things that we can learn from. Today, he's a data manager. He doesn't want me to call him that. We'll talk about that inside the podcast, but he originally came from social science. So Marijn, welcome to the podcast. And why don't you like to be called a data manager?
Because of the negative associations I have with managers since childhood.
Okay. What do you prefer to be called then? What's your title?
My main problem is that many years ago, I started out as a social scientist. Mistakes were made. My dad wondered for years, what the heck is Marijn going to do with his life? But my quantitative approach of sociology, criminology, a lot of statistics, basically meant I was doing stuff like electoral forecasting, pandemic modeling, worked a lot on Ebola. And I ended up graduating on crime analysis for my hometown of Rotterdam. And Rotterdam has a lot of crime. We have 80% of all cocaine in Europe passing through our harbor. So then I graduated, and I was still a data and statistics nerd, which was not sexy. Then I started looking for a job, and they said, wow, you do algorithms to say who gets stabbed and like how many times? Yes, that's data science. So then suddenly I was a data scientist. I had to say yes because I wanted a job. This is Clary. Welcome to the podcast, Clary.
Such a cute little cat for those who aren't watching.
My 4-footed partner in crime. But the main thing here is then I became a senior data scientist because for some reason they liked me. And then I became, what's next after senior? You're managing, lead, whatever. So I became a managing data scientist, which leads me to today when you look at my title and you call me a manager. But that's not what I worked for, man.
All right, I understand. So we'll call you a managing data scientist then. So you have a team of other data people underneath you, right? Is that correct?
Pretty much.
Okay. And so you come from the social science background. We'll get to more of that here in the case, which is not, by the way, that is not necessarily a math degree. That is not a computer science degree, right? That's not like a typical background. I don't think there are typical backgrounds, but in your team, does everyone have, a math background or a computer science background? Tell us a little bit about your team makeup.
Oh, there is no singular background. Like the big joke we've had for years within data. So social science in itself can be very qualitative or very quantitative. Especially the American variety is usually, to stereotype, slightly more qualitative. My team, you have the old data science joke of take 4 computer scientists, stuff them in a box in a room with data and expect magic to happen. This is why so many organizations 5, 6, 7 years ago failed to leverage the data science and back then big data boom, because just get some computer scientists and expect them to do magic with data doesn't happen. I nowadays run teams where we have theoretical mathematicians, psychologists, econometricians. There's this guy who knows everything about Boeing's airspace. There's one who did either astrology or astronomy. I keep mistaking the two, and he gets angry at me when I do that. But the main point here is that we all have big differences in backgrounds. That's why we see different problems. But that's also why we together end up creating better solutions. We just have a whole lot of arguing in between. Because data science traditionally is like 3 things. It's programming, statistical modeling knowledge, and a domain you apply it in. And no data scientist, listen to me, students, no data scientists masters all 3, especially not straight from the start. You either come from a methodological statistical background, or you come from a computer science programming background, or you come from a domain like economics or psychology background, and you start applying the other 2. And this is why it's so important for me in my teams, because you're never alone. You work in a team. You know which bits you're good at and which ones you're less good at, so you can work together as a team. The perfect unicorn data scientist doesn't exist. And if they exist, they're probably too expensive for you.
I love that, because hopefully it's giving hope to everyone listening that, like, you don't necessarily have to have a math degree. You don't necessarily have to have a computer science degree. You can use your domain knowledge, right? So when you got started, you kind of had been doing some stuff in school, like some stats classes and some, like you said, some quantitative research that you've been doing in school. So you've been doing some statistics, right? But then you rebranded it. You called it data science. You got all of a sudden you're more, you're more sexy.
For the record, my master's was policy analysis and big data, because back then everything was big data. Do you remember those? Like, those memes were like, it was a different time. But yeah, I started out with the terrible thing called SPSS, if anyone in the crowd knows SPSS. But from there on, I taught myself R to do more advanced analysis. I was scraping Twitter in like 2013 back in the day. And from there, you branch out into Python, because basically, for my field, what I need is run regression analysis, random forest, XGBoosts, whatever. So it was very much a behavioral study focus. And then like 2 years ago, so quite into my career, I had the question, gender pay gaps. This company telling me, no, we no longer have a gender pay gap, because it said so in our year report that we no longer have one. And I'm like, I read a paper about this like 10 years ago about how you use regression analysis to calculate a gender pay gap for a company, to figure out which parts of your company you're paying too little. And with all due respect, I've grabbed all that paper stuff, and now we rebuilt the same thing in Python. But from a modeling perspective, from a science perspective, we were doing the same thing as what a bunch of scientists have been doing 10 and 20 years ago. But nowadays we're just scaling it in a data pipeline so you can automatically run it every year. Because data science, end of day, is applying scientific methods to solve data problems for people. I'm not sure if Sun Tzu said that, but he should have said that. And that is my example of how I use my background to this day in my field, though I had to get a whole lot better at, not creating spaghetti code.
Yeah, for sure. I mean, I think we all kind of write spaghetti code at the beginning. I help a lot of teachers. A lot of my students in my program are ironically teachers. They're high school math teachers in the US, or elementary school teachers in the US or Canada. And they are like, I don't have, my background is in teaching. Like, how is that going to be useful in the data field? But it turns out a lot of them end up landing roles that use the education background, whether it's at a school district or in some sort of like educational nonprofit, and it ends up being useful to them. So it's cool to see, at least, hear your social science being used in terms of like, how does a business know if they have equal pay, right? What are some other use cases where you've gotten to use your social science background to use data and like combine the two? Can you give us a couple of examples?
Like, there's examples all over the place. I work for Capgemini nowadays as a consulting firm. So one of the biggest consulting tech firms within Europe. So through that, I get experience in all kinds of governments, financial organizations whose names I cannot currently mention, but I can give you some examples. I spent a lot of time modeling refugees, so flows of refugees cross country. That's actually part of my whole background to get into data in the first place, was like way back WikiLeaks, if you remember that, Afghanistan and Iraq wars, and trying to model that stuff. And all that came back to me when I was building models for parts of the Dutch government to analyze flows of refugees across countries, for which I used, of course, the Big Mac Index. Does anyone know the Big Mac Index?
I don't know what it is.
Dude, you're an American. You need to know the Big Mac Index.
All right, I'm
It's
here to
like,
learn. I'm here to
you
learn.
created the standard. So it's the price of a Big Mac for every country in the world for every year. So the changes, the delta you have of changes in Big Mac prices is often a better financial indicator of like prosperity for the country, for the nation, than the statistics released by some of their governments, if you get what I mean.
Oh, wow. Okay.
There's one big outlier in here, and that is India, because India does not have a Big Mac. They have a Big Maharaja. I tried it. It tastes exactly the same, but it's with chicken. Just so you know, FYI. So if you have the delta of like there's the price of a Big Mac goes up from 2015 to 16 in this country X, then 2017, you will likely see more refugees from that country heading towards, for example, Europe. And this is nothing about analyzing yes or no asylum cases. This is about caseload management. This is about having estimates of how many cases you will need to handle, how many beds you need year over year. And it's been a while since I was modeling that, basically because COVID screwed up a lot of these models.
Yeah.
But for a while, it was in Europe, we were able to use hamburger prices to analyze this sort of stuff. Giving me really weird looks like, man, where the heck are you getting this stuff from? Hamburger prices. And I'm just like, there's this paper by this Norwegian dude from 3-4 years ago who wrote about this and tried this. And again, data science, applying scientific methods to solve data problems. If I'm modeling something, yeah, sure, the first thing I do is check Git, but the second thing I do is check Google Scholar, and I start reading a few papers by people smarter than me and how they did it, and then we copy-paste that. We don't just copy-paste the Git code, people, or the ChatGPT code for that matter. We can be better. We can copy papers.
I like it. Read some papers on it. That's awesome. Okay, cool. So you've worked on some of the data problems you've helped solve as, I'm going to call you a data social scientist. Is that okay? I like that term.
I pretend to be social. Yeah, sure.
Well, no, you're solving social problems like the gender pay gap, like refugees. I think that's pretty cool. Like some other things that people can maybe think about like that you might solve would be like burnout, maybe how people interact with one another, those types of things.
I've worked on burnout models as well. So that's actually a public case by now. Burnout and attrition models, if you have large amounts of HR data, so if you have a large organization, you can to some extent get risk scorings for individuals for like over a year, not a specific time, but long term, who is at low or high risk of a burnout. But it's not certain. And you obviously can't go to the person and say, hey man, the computer user says here you're at risk of a burnout. That ain't gonna help. But what you can do is run that analysis at scale. And if you have an interpretable model, and then we are again back at random forest and regression rather than XGBoost and deep learning, you can look at what the biggest predictors are. And for large organizations, not just at the micro level, this guy is going to drop, but at the macro level, what are our biggest predictors of this stuff? What can we address through policy? That is actually of incredible value to so many organizations worldwide. And sure, there's stuff like age or marriage, which is kind of hard to change for individuals through policy, but there is stuff like reward bonus systems, pay raises, travel time, hour time, which manager is like, that's all stuff you can change. And that's all stuff you need to measure, not just through business intelligence and data, but by running statistical analysis. And that's, again, social data scientists coming in. We've been building models like this for over 15 to 20 years already. Heck, most of the statistical methods that we use nowadays were made and developed to harness and capture causal mechanisms, to measure how hard it's discriminating minority or women or LGBT or whatever. Yet nowadays, in current discourse, we are all scared of discriminating algorithms, which is so weird to me because I want my model to be biased, to be discriminating, because that means I'm capturing the issue and I can measure it and I can control for it. Whereas if there's no bias in my model, I get very scared because I'm pretty damn sure there is still bias. I'm just not measuring it and I can't see it and I can't do anything about it. So please be happy when you have biased models. That means you're doing good because unbiased algorithms do not exist, just like unbiased humans don't exist. And we need one to control for the other.
Interesting. I like a couple things that you said there. One, as a social data scientist, you're going to also be working with people data at the end of the day. And you talked about the attrition stuff. So actually in let me think here, in module 8 of my bootcamp, the Data Analytics Accelerator, we cover attrition data from IBM. So we kind of do the same thing that you mentioned. We make a linear regression
that data
model.
set was my first test, of course, because everyone wrote about that. There's so many papers about it. So, yep, you can work with that.
Yeah, exactly. So yeah, we use kind of a famous data set for that one, the IBM attrition data set, and make a pretty standard linear regression model. But I like what you said because like those models, although really simple, like linear regression doesn't sound sexy. A neural net, that sounds sexy.
It's 90% of AI in production is regression.
But that's not fun, and no one wants to hear that.
No, it's not sexy, but this is the same thing as they start calling it all AI in your sales deck. Then as soon as it's sold, they start calling it an algorithm because that makes it less likely the data privacy officer will keelhaul you. It's all psychology and influencing and marketing, really.
It's a dumb title.
Look at the new Europe AI Act, where they kind of fail to identify AI as anything more than, something involving statistics. So anyone listening here, anyone who ever did a statistics course, congratulations, you're an AI expert according to the European Union.
Yeah, that is super true. And a lot of people who are getting started with data, they're like, I want to do machine learning. And I'm like, great, let's do linear regression, multivariate linear regression. But they're like, oh, that's not very cool, right? But that's actually what's actually being used in industry. I use that at my time at Exxon. I use that at my time at VaporSense. We used linear regression quite often. And one of the main reasons we like to use it was because, like you said, it's explainable, right? And you can actually go back and say, okay, this is kind of what's happening, and this is why. This is what this variable is doing. This is what that variable is doing. And in Europe, especially, you can't really have a model that doesn't have explainability, right?
You can totally have a model that's not explainable, but you're going to have a big struggle to get people to believe it because, again, you're going to get a burnout. Computer says so. Does not work. Like, I'm going to be honest with you. I love the H2O stack. Been using it a lot years ago because it basically allows you. It was one of the first AutoML cases where you can just throw your same train test data set into a regression, random forest, neural net, and XGBoost model to compare performance. But in the end, our job as data scientists, it's not to build a model, but to pick the right model and then build that. And it's always an equation between accuracy on the one end and explainability on the other hand, and to find the right compromise between the two. Because if you can't explain why your model is saying it, business won't believe it, business won't be able to use it, business won't be able to prevent it. If I say you're going to sell this much beer next month, good for you. But unless I also explain it's because of the weather and because of the bonus action, marketing says it's purely because of the bonus action, and because, like Feyenoord, because footy is on TV, then we can actually make it actionable. And for that, we usually need simple methods rather than complex methods. So our job is to balance the simple and the complex methods, not go all in on deep learning, as, don't get me wrong, as cool as that can also be. But they're all tools in our toolbox, and our job is to be a tool master and not a fool with a tool.
Yeah, I like that. So all those people who are listening and they're new to the data space, and you're like, oh, I need to learn neural nets, or, oh, I need to learn XGBoost, or, oh, all this stuff, right? The answer is, sure, you can learn those things, but they're not necessarily even used that much in industry 100% of the time. They are used in different places, but like, especially when you take more traditional companies, like for instance, when I worked at ExxonMobil, for instance, one of my jobs at ExxonMobil was help decide how much gasoline we should ship to different gas stations throughout the year, right? Before I created an algorithm to do that, guess what? That was a human's job. And in fact, it's still a human's job. They just use the tool that I created to help aid their decisions. Because the majority of the time, it's very rare. I mean, there are hedge funds that run, algorithmic trading, and it's computers making the decisions with no human inference. But the majority of the time, humans are still making the decisions. They're just using the tools, the AI, the data to help them make those decisions.
It's very good that you mentioned the algorithmic trading case, because that's one of the few cases where you need like lightning quick responses, so you can't have a human in between. But that's a fraction of the total amount of cases. And indeed, usually it supports human decision making.
And you're right that we have to, if, for instance, if I am helping, these were called traders, I think, at the time, that were sending these different gasolines to different places. They've been doing this for 20 years. And all of a sudden, some 20-year-old comes in with a hotshot algorithm that says, no, we should actually be sending this amount of gasoline. It's like, okay.
And you ask why, and you go like, no, that doesn't work.
Because the computer said so. That's not a reasonable response for these people.
Don't get me wrong. Individuals and consumers are more than happy to use this. This is the real reason generative AI became such a thing, large language models, since December. They don't call ChatGPT a Google killer because it has better, more explainable answers than Google. No, but they're just easier to use, because with Google, you have to click 2-3 links before you get your response. And here you just get one straight away. And individuals and consumers, blah, 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 we care less about the actual explainability and accuracy of it. But at scale, especially as a company or as a government, and they can sue your butt for all kinds of things, then you can't do that. And here we have, again, sociologists, we have the individual rationality leads to macro level irrationality, like Coleman, 1990, that whatever the consumer really likes is actually really bad for organizations, and the other way around. But my God, we love using ChatGPT as individuals. So we go like, can we use that in exactly the same way for us as a company, as an organization? And that's just really interesting stuff these days, because there's so much shit happening.
Yeah, it is. It is a good point that we as humans love ease, but in businesses, we love money, and we have to make sure that we're making money. We're making good money decisions.
Not just about money. Come on. I prefer to be talking about, about human lives. I like to play with that, but that means I'm making a difference. So some of the hardest, toughest projects or weirdest stuff I've worked on, in a way, like there's this collaboration between Capgemini and the World Food Program right now to help build a new data platform for them to help analyze how to feed as many people as possible as cheaply and as efficiently as possible, including like 200 food prices, 200 nutrient values. So, okay, grain prices are crazy since last summer. How do we compensate? Do we feed more maize? Do we subsidize broccoli? Do we import stuff, or do we just hand them out vitamin tablets? What is the cheapest way to close the nutrient gap, which is about more than just starving, but also about lack of proper healthy food? This is crazy stuff down the line, because you're using this to advise governments, and better calculations means more people fed down the line. Bad calculations or mistakes or stuff, that means less people fed. That could mean people dead. That's crazy. That's scary. Yeah. But it's also so important to have data for such decisions and to not rely on your gut feeling for that, because that is the status quo. If we're talking about, but data-based decision-making scary, the status quo, no data, is even scarier, because then you don't even know what you're doing, and you can't even measure what the outcome is. So next time you'll do it again. And I'm just really proud to be able to work with the people who actually built those models, who actually help people. We just do the tech support, basically. But that's also data science.
Yeah.
And it changes lives, and that's where I want to be.
Good. I think that's a good point, that you can make a big impact with data in that use case. And that's a really cool use case. Thanks for sharing that with us. I've actually built a similar algorithm, but it's much less important. I actually took McDonald's menu data and found the cheapest, most nutritional food plan that you can get at McDonald's.
Tell us.
Oh, it's really bad. It's like 2 Dr. Peppers, a side of apples, 2 side salads, and some oatmeal, I think is like what it ends up being.
Okay, I learned something today. Thank you.
Yeah. So I know what you're eating tomorrow for your whole meal.
It'll taste the same, man. I've had a quarter pounder in Chicago, in Japan. I tried to get one in India, but there's only a big Maharaja over there. And to my crazy surprise, it tastes exactly the same. It tastes like, with all due respect, but it tastes exactly the same. And that in itself, from a supply chain point of view, is so impressive because they have completely different ingredient sources, blah, 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 and it tastes exactly the same.
Who knew that we'd be talking so much about McDonald's? Okay, now I want to talk to you about kind of as a managing data scientist, when you're looking at new candidates, what are you looking at? What are you trying to see? You know, especially someone maybe doesn't have prior experience, like what would make someone a good candidate in your mind?
Okay, this is for all the students in the audience as well, or listening in later. Back when I had my first intake, back then, just new graduate, social scientist, blah, 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 I was scared. I was a nervous wreck. I was ruining my intake back then until the guy asked me one crucial question. What was your thesis about, your master thesis? And 10 minutes later, I was done explaining how we can analyze how many people get stabbed and how many people do drugs based on social audits and questionnaires handed out to the population, and how trust between citizens and people checking outside if kids are playing, who checks on them, are actually good predictors for all those types of crime. And then he said, that's data science. Do you want to work here? The main point here was that it's scary. Yeah, I too was scary. But when you're talking about something you actually know about, that's much less scary. Like if you like Dungeons and Dragons or football, then you're usually pretty confident when you're talking about that. So please don't try to focus talking on stuff you know nothing about. Like I tried that during intakes, that really didn't work for me. And on the opposite end, because these days I'm at the intakes, I can pretty quickly find out if they know what they're talking about. If it's like, yeah, I built this AI model, and I ask what tools did you use? Yeah, Python or something. Then it's like, get out. I've had those. Kind of cute in a way. My main point here is that I almost always ask about what's your thesis about, or what was an important paper about, because that gives them a case that they've actually worked on that you can talk about. Because you already have experience. You've written papers. You've done theses, internships. Those all count as valid work experience. Heck, my main role right now at Capgemini is giving new hires experience on pro bono projects like the World Food Program project I just talked about. Because you were working in production with this AWS environment, and it's big stuff, and you're having calls with France. That's experience. You worked with data from this and this client during a guide person during your thesis. That's experience. So if you're having talks or getting questions, try to relate it to something you actually did and tell a story about that. And that doesn't even have to be your thesis or any other paper. I remember being asked about IoT and sensor stuff. So I just loaded up my phone and connected to my Raspberry Pi over there in the hallway that connects to most of my lighting, my coffee machine. I have voice controlled coffee. It's like really nice. Here you can do the front door. If I push the button now, there will be coffee on my floor, so I'm not doing that. All kinds of stuff. You're tracking the police radio, so if there's a fire nearby, I can go watch. There's no fire right now.
Okay.
So I can.
Good.
Otherwise, I'd have to quit.
Yeah, you'll stay. I'm so glad.
Yeah. So all kinds of monitor stuff, and that was a hobby for me because it was COVID and I was bored. But I learned a lot from that. And then they asked, okay, what type of connectivity should we use for your sensors? I'm like, well, Zigbee has this and this advantage because I have to build that for my own. And they want to see, they ask, prove it. And I just grab that phone and show them my house.
Yeah.
And that is more convincing stuff because I did that. And that can also just be a paper who gives a damn, or a citation. Then you are strong, then you're confident because then you're talking about your expertise. So always try to guide the conversation and the questions towards your expertise. If the expertise they're asking for then turns out to be something different, then you didn't mess up. When you don't get the job, then you dodged a bullet.
Yes. I love that because interviews can be really scary, but if you can somehow switch the interview to be stuff that you know versus stuff that you don't know, I think that's really impactful. And one of the best ways is, I don't know about you, maybe you're a good interviewer, but a lot of interviewers prepare 5 minutes before the interview what they're going to ask and stuff like that, right? And so they're not very prepared. And if you can provide them, hey, here are 5 projects I've done about 5 things I'm really passionate about or things in this industry, all of a sudden, they're not going to ask you, like some dumb hard SQL question. They're going to be like, tell me about what you did in this project. Explain why you did it like this. And then all of a sudden, instead of just like you having to respond to random questions that you don't know the answer to necessarily, you get to tell them about stuff that you do know. And so if you can show your passion and flip it on the side like that, I think that's really valuable and way easier.
Then you are in control.
Yep.
So please do manage to be in control. So on the side, I've been a dungeon master for 6-7 years.
Cool.
Which is a Dungeons and Dragons thing, like role playing from Stranger Things, not the other thing you might associate it with. But being like the leader of that bunch at the table during the conversation actually taught me more about handling teams and keeping like 5 people with attention deficits on the same story, on the same line for like 4 or 5 hours at a time. Taught me a lot about how to manage teams, how to keep people engaged. And that was also experience. So when they asked me about, can you lead teams? Legit, I started talking, or how would you handle this case with a team? I just started talking about how I handled my D&D teams. And that was also valuable experience.
Yeah.
Please don't tell yourself that you don't have experience or that you don't have value. You just don't freaking know it yet. And the only way to find out is by having some mother fluffer ask you all those 50 questions and you go like, and then later on you go like, oh, I should have talked about this hobby project of mine. And then next time you get the question, you are better prepared, because it is a dice roll. And the best way to win a dice roll is to keep on rolling until you get a 20.
Yeah, I love that. I was going to make a post about this on LinkedIn today. I don't think recruiters or hiring managers reject data analysts the most. I think the aspiring data analysts reject themselves the most often. Like, and it's so sad because you don't think you have enough experience. You don't know, what a neural net is or how to build one. So you think you're not qualified for a lot of these roles or whatever. But the honest truth is you should make someone else say you're not qualified. Don't be the person to say you're not qualified.
Any recruiter will only spend a minute tops talking down on you. The rest of the day, it is yourself talking down on you, or in my case, my cat. Now, the main thing here is you are your own worst enemy, but you need to face your fear, so you need to face yourself. And the best way to do that is not by repeating the conversation over in your head 50 times, but through practice and experience. In the same way that I tell everyone, please talk about your experience. Please talk about your thesis. Tell me what went wrong. What was the data quality? Yeah, the data quality was shit. Yeah, of course it is. It always is. How did you fix it? How did you deal with it? That gives you tools to work with.
I love it. And that kind of goes on our theme of you don't have to be a perfect data scientist, data analyst to be one. If you're trying your best, you're learning, it's usually good enough and you're better than you think you are.
Perfection is like objectivity. It's something to strive for, but something to never reach. Again, I started out with the whole data thing in conflict studies, which is very subjective, if you get what I mean, because we're using satellite images to monitor the growth in mass graves and that kind of stuff. So everything is incredibly subjective. How do you deal with that? Well, not by denying it and trying to pretend to be objective, no, but by admitting your own subjectivity. This is why social science and ethics in general is becoming such more of a thing in the data field, because that's what you need to deal with very sensitive topics that also involve data. Because let's be honest, every single damn field will involve more data from now on. The future is bright for us. But because we need to be subjective and because we need to be able to deal with that, in the same way we cannot be perfect, and there will never be a 100% accurate model with a 0 error rate, even though business keeps asking for that for some godforsaken reason. You need to be able to deal with uncertainty. We as data scientists, that's one of the strongest things we can do to help measure risk, uncertainty, odds, blah, blah. But it will never be 100%, or it will never be 0%, because this is stochastic stuff. The world is not based on rules and zeros and ones. Only our minds try to make things black and white. Occasionally my cat tries to make things black and white, but I digress. The main point here is we have to deal with uncertainty. We are here to help your organization deal with odds and risks and everything. And that is also a big storytelling element. And to strive for perfection for the company or for yourself means denying that in the end it is a dice roll. And please don't start telling yourself that it's because of you, it's causal, it's blah, blah, it's if then. Nothing is if then. It's all odds. So don't beat yourself up over a damn dice roll. Just keep on rolling.
The worst thing you could do is stop rolling the dice. So don't stop rolling dice. Keep the applications going. I love it, Marijn. Thank you so much for being on the podcast. Where's the best place to reach out to you if people are interested in learning more from you?
LinkedIn.
Okay, we'll have your LinkedIn URL in the show notes down below. I appreciate you coming on and sharing your knowledge. We're going to go ahead and take some live questions. Any of you guys are in the audience. I was looking, I think we have like 50 people or something live. If you guys have a question, go ahead and put it in the chat and we'll take a couple live questions here on the show. They could be for Marijn. They can be about social data stuff. They can be about being a managing data scientist. They can be about IoT and Raspberry Pis and stuff like that. So go ahead and put them in the chat. Here's one. From a technical standpoint, what makes a great data or junior data engineer? What kind of portfolios offers the best value to recruiters? Do you deal much with data engineers?
Oh, of course. We always need one. Like any team, you need a data engineer, data scientist, data analyst focusing hardcore on the modeling, and a visual person, and perhaps a business analyst, somebody who can do the talky talk PowerPoint. So maybe a scrum master. So quickly you're filling it in. So yes, I'm going to talk from a European Dutch perspective here because that's the market I know, and our food can be great or terrible depending on the country. So beware. Over here, if we're talking about the data engineers, knowing different clouds is the game, or at least having some form of certification or experience with it. Note that certifications and Pokemon badges are usually compensations for not having experience in something. So build your own stuff for fun is usually more educational than only getting a certification in it. Same goes for classic stuff like knowing Agile. Because if you go to your intake and they go like, oh, do you know how Agile works? And they go like, and you go like, yeah, I have a one-day training in it. That's not going to fly as much. So focus on building stuff. In the Netherlands, it's all Azure. Like, don't get me wrong. I love AWS stuff. I think Google's stuff is cool too. But the market over here is just very Azure saturated. So look at whom you're applying for. And if you know what tool stack they have, then you know what to be interested in. I'm not just saying here, mention the names they want to hear, but tool stacks are important over there. And the other part of my advice is the same that I gave previously, which is to give examples, please. Even if it's just home projects or internships, those also count. You will convince them so much more with stories of I've built this, or just showing them that, than, I don't know, references or more Pokemon names, because the recruiters half the time don't even know all the Pokemons.
Yeah, that's really interesting. I think it's actually pretty hard to go from like zero to data engineer. I don't see that happening very often. Like usually you have some sort of other data related role first, or you have more of a computer science background or something like that. Like, I don't know about you, maybe you've seen this, but I've never really seen someone like, for instance, me as a chemical engineer go straight to data engineering. Actually, that's not true. We just had a student inside of the boot camp who was a mechanical engineer go from a mechanical engineer to a data engineer role. And he actually did it kind of like you said, with like at home IoT data projects, really. So I guess you can if you have really good projects, but from my experience, it's a little bit harder than landing like a data analyst.
I've seen it happen too. If you coming from a computer science or AI background and going into data engineering just because they liked it. But the main thing here is that you don't want to do what everyone else. That's not really a valid model to differentiate. This is an advice for the data engineer as well as for anyone else listening. They will not hire you just because you know a lot about the one title they're looking for. You can differentiate by knowing more about the one topic than all the other applicants. You will differentiate a whole lot better by knowing more about other topics in addition, because usually they're not just looking for a data engineer. They also have a dashboard stack that's completely messed up, or they have like very big data quality analysis issues. They also look for that. So if you as a data engineer start explaining I can also do the modeling, I can actually also do the visualization, they will be much more interested, because say they're looking for one thing, but they're actually looking for 3, 4, 5 things with like a fifth leg from your armpit.
Yep.
And that is how they get interesting to you. They might not even realize this. They didn't prepare this in advance because they only prepare a few minutes in advance. But to use my own example, we were in a team and the question arose from the ethics officer. So does your model discriminate? And they were like, oh God, how do you calculate that? And then I'm like, ooh, I wrote a paper about this because social science background. So in the current field, it's not just about what you know within the field. It's about what you know outside that field. If you can also lead, if you can also draw, if you can also speak and explain, if you can also, I don't know, hook up 50 kinds of crazy APIs. And that is what makes you valuable. So to figure out what makes you valuable, don't be what everyone already is, because this market is kind of saturated with people trying to be everyone else. Don't try to be everyone else. Try to be yourself. Oh God, yeah. I can't believe I actually said that.
No, I like it. I like it a lot. Okay, here's a question. Why is fear-mongering tactics used to subdue the population when it comes to AI or any other technology?
Oh, come on. This is nothing new. Like, the most intrinsic fear of man is the unknown from a psychological point of view. So anything new, and that's not just AI, we are scared of. In the 80s and 90s, teachers tried to ban calculators, graphical calculators. After, we also had schools that tried to ban Microsoft Word and autocorrect. It's evil, it's dangerous. It'll mess up the kids. They won't be able to write anymore.
I can't spell, just for the record.
Me neither, but the main point here is we are still way more productive than had we been educated without a typing engine and only writing by hand. And the schools that did say, oh, we can't mess up our kids, it's bad, conservative stuff, threw out the computers out the window, those students later on were not well off in the labor market because they had more of a distance to the labor market because they didn't have the digital skills. So we're actually, to quote Bruce, if you're listening, I don't think you're listening from San Francisco, but anyway, professor friend of mine once said, the problem isn't that machines write papers as good as my students today. The issue is that some of my students write papers as badly as a machine, and I still have to give them a passing grade because they wrote 5,000 words in 6 pages or whatnot. So we are actually now revising the entire way we deal with education, because in the past you just got an F if you have too many spelling errors. That's kind of out of the equation on the whole these days, thanks to spelling checkers. So we react because it's scary and it's threatening the status quo. The beauty of technology is, of course, that it shall always and at each and every time threaten the status quo. Change is the only constant. So 5 to 10 years, everyone was crazy, scary about big data, about AI. Now everyone's scared about generative AI, and it actively bothers me because the biggest source of discrimination and bias and threats of AI and algorithms in the modern day is not the Terminator future. It's social media algorithms who are hella untransparent, incredibly biased and discriminating. Like, you go on TikTok, you won't ever hear anything about Uyghurs being discriminated in China. Never. And the average 18-year-old in our society is now mainly getting their information from a social media platform controlled by a state who doesn't really like democracy. That is scary stuff. That is the true bias in algorithms today, and we are not talking about it. So the fear-mongering isn't actually, but it's harmless fear-mongering. No, it is actually dangerous because it distracts from the real issues.
All right, that was good. We're going to end on this question kind of about what type of projects are considered most valuable in terms of showcasing data skills. What about the scope of the projects? How do you evaluate the self-initiated projects that use data from the internet? And then kind of a similar one here, like, what about like in-depth ones versus not in-depth ones, a big one versus a small one? Thoughts here?
Target audience, my man. And that also relates to the previous junior data engineer question. You can go very in-depth on like one project, but if the recruiter you're talking to barely knows Excel, you will very quickly derail the conversation. You can explain your entire PhD-worthy model, and they'll still not give a shit about it because they did not understand it. So first step is to know your audience, whom you're talking to, what organization you're talking to. If you know the name of the recruiter, please Google it. Google is free for now. Come on. And that basically determines how in-depth you want to go. If they ask for somebody in the retail sector, and you have 1 out of 3 projects that have something to do with beer sales, please go for that one. Don't get me wrong. I could talk for hours with you about all your hobby projects, and you could talk for hours about mine. But this is usually a less is more thing, because in a pitch or in a moment, you will not have hours to talk. You will have 1 minute. So you can think ahead about which is the most applicable. If they're looking for a visualization case, look up the one that actually looks pretty. Maybe just have a screenshot of that in your phone, because usually my demos die on me. So I have a screenshot on my phone to this day. This still happens. So it's not about just having stuff, it's also about matching stuff. And to be able to match to anything, you just want to have a lot of stuff. So please, if you do an internship in the financial sector, if you're doing a second internship, do it somewhere completely else. This is why I like the consulting sector as a whole, because you will be sent to banks, you will be sent to retailers, you will be sent to, I don't know, I work with NGOs these days. And that allows you as an individual to figure out, okay, what type of environment do I actively like? What am I actually good at? What you like and what you're good at are two very different things. And whereas like the coffee fit for human consumption, and you'll find all of that a whole lot faster if you do internships and like assignments in different places than when you have like a full-time job at one of those places. Then you are slightly more limited in how much data you can collect. And that goes for references, that goes for your projects, and that goes for your experience as a person in your career. And please don't be afraid to fall flat on your face and make mistakes, because especially at the start of your career, we expect you to. The dangerous thing is if you don't make any mistakes that you can learn from, because then you'll be making those mistakes later in life. Last question I saw, how would one showcase their portfolio? Git, baby. Get a Git. Or learn to make a fancy dashboard and host it, because then you have hosting experience.
Man, I love that. We'll end on that. Marijn, thank you so much for being here. Keep rolling the dice. Keep making mistakes, you guys. And thanks for being here.
Like and subscribe. Connect on LinkedIn afterwards. Avery, thank you so much, my man.
Well, you guys, that was an awesome episode. I hope you guys learned a lot. I know that I did. If you guys want to learn more about data analytics, I have some resources for you in the show notes / description down below. Please check those out, and I'll see you guys on the next episode.